I'm pretty sure it's recording, so here we go. So it says consider the function g of x equals x minus 3 squared. How can you restrict the domain of g of x so that its inverse will be a function? So graph y equals g of x with its domain restricted. Okay, so this has a vertex of 3, 0. So, and then here are the points. Oops. So essentially, this left side of the parabola needs to be restricted, and the right side of the parabola is basically what you want to flip it. Because other words, right, if you flip the whole parabola, right, you're going to get a sideways parabola, and that's not a function. So you want to just flip just half the parabola, and then you'll get, your inverse will be a function. So there you go, and then our inverse, right, so if you have g of x is equal to x minus 3 squared. You want to write that as y equals x minus 3 squared. Switch x and y. And then solve for y. So you get the square root of x equals y minus 3. So you just keep the positive, not the negative. If you do plus or minus, you're going to get the whole sideways parabola. But we restrict the domain to just the positive answer. So it's positive square root x. And then you add 3. So g inverse of x is the square root of x plus 3. So our inverse function is plus 3. There, so here is g of x, and this is g inverse of x. So, and you can see it's a reflection along the line of y equals x. Alright, so it says, how can you determine from a graph whether its inverse will be a function? Explain. What are some of the examples of the other functions whose inverses are not functions? Okay, we talked about this in the video. So, if the original function passes the horizontal, excuse my handwriting, good lord, passes the horizontal line test, then the inverse will also be a function. So things like lines or square root functions or exponential functions or like simple cubic functions, right? They all pass, like they only hit just one time, right? Unlike, let me make that a little more obvious. Unlike y equals x squared, right? That's not going to pass the horizontal line test. But if you just do it right here, right, if you restrict this domain, it will pass. Okay, so 5-24. Graph y equals 1 plus 2 over x and its inverse on the same set of axes. Label the graph and its inverse with their function. So what is the equation of the inverse? Let's solve for that first, and then we'll graph it. So, yeah, y equals 1 plus 2 over x. You want to switch x and y, so you get x equals 1 plus 2 over y. And then you want to solve for y. So first you want to subtract 1, so you get x minus 1 equals 2 over y. And then you want to multiply by y. So you multiply by y and you get y times x minus 1 equals 2. Now, usually, like, you're really tempted probably to distribute this y, but that's really not going to help you. You want to divide by x minus 1. So y equals 2 over x minus 1. So this is the inverse function. And it is a function, okay? So you're going to get here, if you plug in, so for original function, right, you're going to have a horizontal asymptote at 1. So let me just shade this. So you have a horizontal asymptote at 1, and then if you plug in 1, you'll get 3, right? If you plug in 2, you'll get 2. Right, and essentially here's your hyperbola. And then here is the other one. Okay. Okay, and then if you want to graph the other one, I don't know, here we go. We'll use this color to show up, sort of. Okay, this one has a vertical asymptote at 1. And a horizontal asymptote at 0. So, like, you can just flip the point. So if this had the point 1, 3, then this one has the point 3, 1, and this point 2, 2. So here's the other graph. You could do this on your calculator too, get some points. But that's what he's in. You can see that they're reflections of each other across there. So what is the domain and range of both the original function and the inverse? Well, the original function, right, the domain, so we'll call it orig. So the domain was all reals except for x cannot be 0. And the range, because that was where your vertical asymptote, and the range was all reals except for y cannot be 1. And then, like I said, for the inverse is, right, like, you can look at the graph, it'll verify your answer, but remember, the domain and range switch. So the domain now is all reals except for x cannot be 1, right, because your y cannot be 1 there. And then your range is all reals except for y cannot be 0. Okay, next problem, 5-25. So it says graph f of x equals 1/2 x minus 1 cubed, and its inverse on the same set of axes. Okay. Let's solve for its inverse. So y equals 1/2 x minus 1 cubed. So we switch x and y. So you get x equals 1/2 y minus 1 cubed. Then solve for y. So get rid of the 1/2 first by multiplying by 2. So you get 2x y minus 1 cubed. And now you need to get rid of the cubed by Yo, you like my nails? I did them myself. It's a hard world out there for those who cannot get their nails done. Oh my god, it's difficult. Anyway, square root, cube root both sides. Jeez. Okay, so he gets cube root of 2x equals y minus 1. Right, and then we're almost done. You add 1. So y equals the cube root of 2x plus 1. Okay, so there's your inverse. And then you can go ahead and use your calculator to graph these. Because, yeah, it's annoying to plug in points. You can see my math there for like trying to do videos. Good lord. Okay. Or when I was like preparing for the videos. Okay, so. Ooh, that's from last video. Okay, here we go. So, our original function, right, was 1/2. Original function was 1/2 x minus 1 cubed, and then our inverse function we said was the cube root. So to do that right, you go to math, and then you can see right here the cube root 4, and then 2x, and then you need a right arrow to get out of it, and then you go plus 1, and then yeah, if you go to your graph, right there, there's our cubic function, and this puppy is our cube root function. And then you just go ahead and like go to your table. Just plot some points here. See, 1, 0 is important for the first one. 3, 4. -1, -4. Okay, this one grows like super fast, so. Yo, not so beautiful. Is it too late to apologize for this poor graph? This is what happens when I've been in isolation for too long. Okay. Okay, and then the other one has a point 0, 1, right? Oh, the opposite, right? This point was 2, 4, so it's going to have 4, 2, right? And this point is 0, -4, so it's going to have this point. So sorry, I look so crappy. Anyways, but that's it. Okay, moving on to the next problem. Okay, so it says, for 5.26, basically was to find the inverses of these equations. So switch to y equals, I guess there isn't really any directions. That's what the directions were supposed to be. So switch them. So 3y minus 8, and then solve for y. So add 8, divide by 3, you get 1/3 x, which is the same as x divided by 3, plus 8/3. This one is y equals 1/2 x plus 6. Switch x and y. Subtract 6. Multiply by 2. 2x minus 12. Okay. Here, switch x and y. Multiply by 2. You get y equals 2x minus 6. Okay, next one says solve the following systems of equations. In other words, find the values of A and B that make the systems true. Be sure to show your work or explain your thinking clearly. Okay, the best way to solve for these both is just solve for A for both of them. So if you solve for A for this one, right, you're going to get 3, you divide both sides by B over 0, and you get 3 over B to the 0 equals A. You solve for A for the other one, you're going to get, you divide both sides by B squared, you get 75 over B squared equals A. Now, since these both equal A, right, you can use the equal values. You can set these equal to each other. So then you have 3 over B to the 0 equals 75 over B squared. Right, this is back from integrated 1, but you probably don't remember, so it's a good refresher, because it is important for this chapter. So then you want to cross multiply, and you get 3B squared equals 75B to 0. And then you want to, you divide by the smaller b, basically. So then you get, you get 3b squared equals 75. And then you want to isolate the b squared, so then you get, let's just put like a little box around here to make my work a little cleaner. Then you get b squared equals 75 over 3. And then you get b squared, then you want to square root both sides. So you can just go ahead and do that on your calculator. Square root of 75 over 3. Brilliant. Because b squared is 25, so b equals 5. So to figure out A, you can plug it into either one of these, right? And then you'll get that A is 3. Right, because then you get 3 over 5 to 0, which is 3 over 1, which is 3. Or 75 over b of 5 squared, which is 75 over 25. And that's 3. Okay, same process here. Solve both of these for A. So then you get 18 over b squared is A. And this one you get 54 over b cubed is A. Right, and then you use equal values, set them equal to each other. So it's 18 over b squared equals 54 over b cubed. Cross multiply, you get 18b cubed equals 54b squared. Right, and then divide by the smaller b power, so then you get 18b equals 54. Then divide by 18 both sides, you get b equals 3. Okay, and then plug that into any of those. So, right, if you plug in 3 over here, that's 18 over 3 squared, which is 18 over 9. So A equals 2. Okay, next problem. It says Lacey and Richens, weird names, right? Each have a personal function machine. Lacey's machine is L of x, makes sense. It squares the input and then subtracts 1. And then Richens' function machine, R of x, adds 2 to the input and then multiplies the result by 3. So write the equations that represents L of x and R of x. So L of x, it says it squares the input. So input is always x. So it squares input and then subtracts 1. And then it says Richens' function machine, so R of x, adds 2 to the input, so first adds 2, and then multiplies the result by 3. So it multiplies all of that by 3. So you could simplify that if you want to 3x plus 6. So Lacey and Richens decided to connect their two machines so that Lacey's output becomes Richens' input. So if 3 is in the initial input, what is the final output? So if you put 3, you first put it into L of x, right? And then you get 3 squared minus 1, which is 9 minus 1, which is 8. And then that goes into R of x. And then that you plug it into here, so then that's 3 times 8 plus 6, right, which is 24 plus 6, which is 30. And that's the final answer. Okay, what if the order of the machine changed? Would it change the output? Yes, it would. Okay, so for example, if you put 3 into R of X first, right, then you'll get 3 times 3 plus 6, which is 9 plus 6, which is 15. And then if you put that into L of X, then that's the input squared, so 15 squared minus 1, right? And then 15 squared is 225. And then subtract 1 is 224. So if you go the other direction, right, if you put 3 into R, then L, instead of L, then R, right, you're going to get a totally different number. So order matters, yo. Okay, and graph y equals 5 times x minus 2 and its inverse on the same set of axes. Label the graph in the inverse with their equations. Okay, so 5 times x minus 2, let's simplify that. That's 5x minus 10. So we'll call that the orig. So 5x minus 10. Okay, this function has a y-intercept of -10 and a slope of 5. And then the inverse function, right, you want to switch x and y. So x equals 5, y minus 10, and then you solve for y. So you add 10, then divide by 5. So you get 1/5 x plus 2. So you get 2. Alright, you can see the points change, right? I had 0, 2, or I had 2, 0, now I have 0, 2. I had 2, -5. Now I have -5, 2. And so here it's its inverse. So this is the original, and this is the inverse. Okay. Next problem. It says, look at the graph of the function, its inverse, showing it right. If h of x is a function and inverse of x is its inverse, can you tell which is which? Why or why not? No, you cannot tell. Right, because they're both reflections of each other, so it doesn't really matter which one can come first. Okay, and the function f of x is represented on the graph at right. Draw a graph of its inverse function. Be sure to state the domain and range for both f of x and f inverse of x. What is the relationship between the domain and range of the original and the function and the... Okay, right, we know the domain and range switch. Okay, and then you can just like replot the point. You can make a table if you want. So if this is f of x, right, if it helps you. Okay, this point here, right, is -2, -3. Then that point 0, -2. This point is 1, 0. This point is 2, 2. And then this point is 5, 3. And then you can make your f inverse of x function and then plot all of those points. That can help you. So then it's flipped, so -3, -2, -2, 0, 0, 1. That stays the same, 3, 5. Okay, so -3, -2, -2, 0, 0, 1, 2, 2, and then 3, 5. So then you just connect them. There you go. So the domain for the original, right, we know is between -3 and 5, right? So it goes far as left as -3 and goes far right as 5. And then the range, right, it goes as far down as -3 and then as high up as 3. So then for the, you can check on your graph, but you don't really need to. So for the inverse, remember it's switched. So the domain then will be -3 to 3, right? That's true. And then the range should be it should be what the domain was. So -3 to 5. So there you go. Alright. Thanks for watching. Hope you're doing alright. Miss you. Bye.